There are a number of statistics that are used to describe personal networks. They include connectedness or degree, the number of links, or the total amount of communication, integration or density, the percentage of nodes links that are linked to one another, and centrality, which is the average distance of a node to all the other nodes, that is, the number of steps required to reach all others. At the system or whole network level, there is connectedness or density. It is defined as the number of links divided by the number of possible links. The number of possible links is the number of possible combinations. It is equal to the number of nodes times the number of nodes minus 1 divided by 2. System integration is the average of which nodes links to a focal node are linked to one another. And system openness, the degree to which nodes are linked to external nodes, that is, what percent of the total links are to outside the network. Let us make some simple calculations to determine the density of the small groups we described earlier. First, the number of possible links is n times n minus 1 divided by 2 is 5. The number of nodes, n is 5, or the number of nodes in each of the small groups times 4, n minus 1, which equals 20, divided by 2, which equals 10. Now, let's count the number of links in each type of the small groups. ComCon has 10, the wheel 4, chain 4, and the circle 5. ComCon, 10 divided by 10 equals a density of 1. The chain divided by 4 divided by 10 equals 0.4. Wheel has 4 divided by 10 equals 0.4. And circle, which has 5 links, divided by 10 equals 0.5. Very simple. And for the organization presented in slide 18, which has 24 nodes and 36 links, therefore it has a density of 0.13. Why don't you try to do the calculations yourself? In the small group example, we talked about how node 3, the hub, was more central than the other nodes. And in the organizational example, I mentioned that the president, the liaison, was more central in the information flows of the organization. Well, there are a number of different measures of centrality to indicate a node's relative centrality in the network. They include degree, which is a node's number of ties or the sum of the strengths. These links are typically differentiated into in degree, the number of ties that a node receives, and out degree, the number of ties that a node initiates. In degree is often considered a measure of a node's prestige. Another statistic that indicates a node centrality is betweenness. Betweenness is the proportion of all the paths linking A and C that pass through B, our focal node, sum for all nodes. In the small group example, for the wheel, all paths pass through node 3. Therefore, it has a centrality of 1. Since no paths pass through any of the other nodes, they all have a betweenness centrality of 0. For the chain, node 3's betweenness is 0.8, since 80% of the paths pass through it. For node 2 and 4, betweenness is 0.6, and for nodes 1 and 5, it is 0, since no paths pass through those nodes. Betweenness is often considered a measure of information power, since the node with the highest betweenness centrality has the greatest control of the network's information flow. Still another measure of centrality is closeness. It is defined as the reciprocal of the sum of the lengths of the shortest paths to or from all the other nodes. For ComCon, all the nodes have a closeness of 1.0, since all other nodes can be reached in one step. For the wheel, node 3's closeness is 1.0 for the same reason, but all the other nodes' closeness is 0.57. And for the chain, node 3 is the closeness to all the other nodes. 6 is the sum of the steps required for it to reach all the nodes in the chain. Thus, its centrality is 0.167. For nodes 2 and 4, it is 0.143, and for nodes 1 and 5, 0.1. As I showed with the examples, networks are composed of subgroups. Groups are sets of nodes that communicate more with each other than with the other nodes in the network. Groups are often called cliques, factions, clusters, or communities, depending on how group membership is determined. In cliques, everyone in the group communicates with each other node. In factions, the majority communicate with others in the group, but a small proportion can be with non-members of that faction.